Good morning. Not even 20 students are there. Do one thing, you can start sending your attendance. Maybe one after the other messages ring on their phone. They get up and join the class. Still, number has not increased 20, not even half. Fine then. If these are the number of students who want to join, we can be happy with that numbers only. There was one thing which I had not told you in a hurry. We just shifted from FCFS to SJF. That was a term by the name convoy effect. Search for it and let me know what is convoy effect. I have given you a hint also. It was in FCFS. I'll write in the messages. Let me read what has. It must be Aditya only. Yeah, Aditya is the one who has replied. Abhinav also this time. Okay. Saksham also. Tomorrow college is reopening. So everybody is like one process can use the CPU at a time, so processes could be slowed down due to this effect. When a few slow processes cause the entire OS to slow down, phenomena occurs when a CPU bound process monopolizes the CPU, causing other IO bound processes to accumulate in the ready queue. So you will learn these answer and write it in your exam. In which scheduling algorithm it is observed? Which example you will give? FCFS. Okay. So before SJF, please write down this as a note if you have left some space, or you can make a star and first write this, then we will do the other algorithms. Convoy effect and how a CPU bound process slows down other processes. This is known as convoy effect. It is seen in FCFS. I hope you have all written. Should we move to the next algorithm? It is called SRT, shortest remaining time first. In bracket, you can write down the preemptive version of SJF. So now we have to do SJF. सेव तो कर लिया preemptive SJF है ना ये What's the name of the next one? Shortest remaining time first. SRT. So in bracket you can write down it is the preemptive version of SJF. What it will do? When CPU is available, then it is assigned to the process that has smallest अपने लिए लिख लो next CPU burst. Write down this, then we will do this example. Shortest remaining time algorithm does what? It will preempt. SJF was non-preemptive, but this is preemptive. Fida, how have you been able to join? You have returned to Delhi
Ma'am, I am returning today evening.
today evening by flight.
No, ma'am, by train.
So you'll be able to come to college tomorrow morning.
No, ma'am, it will take 2 days to reach there.
Oh my god, then why didn't you get it done earlier? The message was very clear that college will open tomorrow.
Yes, ma'am, but the train tickets are not available. That's why.
Oh god, such heavy traffic.
Yes, ma'am.
I can't understand the reason why. What is the logic? Is there some festival in Kerala this time?
Uh, no, ma'am, but it's still not available. I just took the ticket in Tatkal. That
Oh god, it's that bad. Maybe the reason is that most of North Indians are visiting Kerala because it's been cold here. So people rush to southern states and now
yeah,
they're, yeah, yeah. Because today I thought the students will say, ma'am, don't take a class, we are on the way, and network issue is there. That's why yesterday night I asked, should I take a class or there is any kind of difficulty with you people? But I suppose network is good in India now. At the time going home, you were tired with your मैम फायदे ने एक बुक लिखी है क्या क्या लिख रही है जया
मैम फिदा ने एक बुक लिखी है और वो इसलिए अपने घर गई है। मैम वो
अच्छा
पब्लिश भी हो गई और मैम वो न्यूज में भी आ गई। हम बहुत खुश हैं, हम कल फिदा से मिलेंगे।
वो तो कह रही है 2 दिन लगेंगे आने में अभी
हाँ मैम, मतलब वही 2 दिन बाद मिलेंगे।
मुझे लगा मुझे झूठ बोल रही
नहीं है।
congratulations Fida that's good
थैंक यू मैम।
okay it's pertaining to computer science or some other issue
It's related to astrophysics.
oh great you can get it to the college if you wish to we can also have a look
Yeah, ma'am, sure.
yeah yeah in the achievements of the department this time Suruchi Gautam madam is the teacher in charge if she feels so she can forward that concept and your name would be spoken out in the annual day.
Okay, ma'am.
I'm not here for sure but you will have to approach her and then the person who is in charge of everything on the annual day if you are willing to take that much of effort because students though just come to take their prizes. Okay, I'm just letting you know that if you feel so you can tell the TIC. She might get interested in the topic also and show to other teachers. Okay. The fact that,
Okay.
yeah, Jaya has shared it with me, so I've shared my viewpoint. Very good, Jaya. पार्टी लोगे इससे?
नहीं मैम, बस बहुत अच्छा लगा, खुशी हुई।
Great, great. Very nice. Chalo, let's continue. So we were on that numerical. Okay. You people have copied the question? Okay. You have copied the question. So I'll open. So we are having 4 processes. This is SRT. So, what is happening? Process P1's arrival time is 0 and its burst time is 8. So at time 0, process 1 enters the system, but you see at time 1, next process enters, thereby it will not allow P1 to execute for its full time. P1 will execute only for one time unit. Then P2 has entered the system, and by luck, its burst time is of 4 units. Hence, this will execute to its fullest and run up to 5 time units. क्योंकि ये shortest remaining time इसका है. P1 still has 7 more time units to consume of the CPU, but P2 will leave the process earlier by using 4 time units. Hence, CPU goes to P2. Now, in the meanwhile, both the processes have entered P3 also and P4 also, because their arrival times are 2 and 3, and we have reached the time what?
5.
Yes. So now you have to consider at time 5 which process will now get the CPU, whose time remains the shortest. Tell. Till now, all the 4 processes have entered, whose time is now left the least. सबसे कम अब किसका टाइम है? P1 को चाहिए अब 7 टाइम यूनिट्स के लिए, P2 को चाहिए ही नहीं, P3 को चाहिए कितनी देर के लिए? 9 के लिए, और P4 को चाहिए 5. ठीक है, तो ये 5 टाइम यूनिट्स अब P4 को देगा. अब कौन सा छोटा बचा? P1, उसके बचे 7 टाइम यूनिट्स. और अब we are left with P3 for 9 time units. 17 plus 9, 10 होता तो 27 minus 1, 26. So this is the Gantt chart you have to prepare. You can write in your notebook or take a screenshot. So all clear? Ma'am, can you show the numerical question again? Okay, I'll scroll up. This is it. These are the processes P1, P2, P3, P4. These are their burst times and these are their arrival times. Now we have done today SRT. When CPU is available, it is assigned to the next process that has the smallest CPU burst. This is what we have done while solving the numerical. Is that okay, Aditya? Okay, thank you. Next question. Try it out. Process P1 arrives at zero point 0.0 time. Its burst time is 5. Then the next, it can also be given to you like A, B, C, D. Any kind of naming can be done. Okay. A process processing time is 5 units. Process B has processing time 2 units. Process C 5 and process D 3. First tell me one thing, maths class कितने बजे है आज?
Ma'am, actually, it is not confirmed whether today we have maths class or not. Sir will inform afterwards
Okay.
because there is a meeting.
Because tomorrow your meeting online and offline thing will finish. That thing is there. Okay. Okay, you can send me his phone number, please. Because after this, I have to go to college. I have to go and talk to him. You can share his number. Tomorrow, you know, now you have to get your files. We have practical tomorrow. Those who want to get it checked on tomorrow, you can bring your programs. And tomorrow, I will do Unix. Chalo, let's start with this question now. Process A is arriving at time 0 and process B is arriving at time 1. So till 1A can do its task. Because at time 0 only A is there. Then at time 1 B comes. It will preempt the process A. Why? Because how many time units it has to work? Only 2 time units, whereas process A has 4 more time units left. So B will preempt A and take over CPU and it will work for 2 time units. Got it? Why A is preempted and why B has taken over? Okay. Thank you, Aditya. Next, what is happening? At time 2, we see that C enters. अब C को मिलेगा कि B चलता रहेगा? हमने B को चलने रहने दिया. Why? Because सबसे कम किसका बचा था? B का. इसलिए टाइम यूनिट 2 पे हमने C को नहीं करा. Now at time 3, B terminates and D has entered. तो हमारे पास अभी A बचा हुआ है और C बचा हुआ है और D बचा हुआ है. सिर्फ B का काम खत्म हुआ है. अब यहां पर किसको देंगे?
D.
यस, D का सबसे छोटा है 3 टाइम यूनिट्स, तो वो 6 तक चलेगा. ओके, D फिनिश हो गया. अब कौन रीस्टार्ट होएगा?
A.
ए. वेरी गुड. ए का कितना बचा था? 4 मोर, है ना? 1 यूनिट मिल गया था उसको, उसके 4 और बचे हैं. तो 10 तक ए चला और अब कौन सा चलेगा? सी. I hope it's clear now. आज वाला एल्गोरिथम क्लियर हो गया? So now you have done 4 algorithms. First come first serve, shortest job first, shortest remaining time first, round robin scheduling. All of you should know these now. Should we do the last one, priority scheduling? You have all copied the Gantt chart, which we have just now done. You have to tell me whether I have to again do this with you or should I proceed? How do I know? 2 numericals we have done. Okay. So let's do this thing also. Manjeet is also staying. All right. Understood now how you will handle this question if they are saying do it by preemptive algorithm. That means you yourself have to apply SRT. Okay, don't get confused कि कोई नाम नहीं दिया हुआ. They can also give this thing, use it through preemptive SJF. That means apply SRT on it. We have done the examples today and you have become quite confident about it. So now let's begin with the priority one. So now burst times are there of the three processes and their arrival times are also there. Burst times are there, arrival times are there, then their priority is given to us. The first one having priority 3, next one having priority as 2, and lowest one having priority as 1. So let's take that smaller number means high priority. Okay, so let's do it by preemptive priority. Fine. I hope the question you have copied. Copied, please.
Yes, ma'am.
Everyone, please. Okay. Manjeet, Aditya, Sachin. Who else has it?
Yes, ma'am, copy.
Saksham, Vansh, and all. Abhinav. Okay. So try and understand this question. Who is having the highest priority? You have been told. Okay. Smaller number means higher priority. So at time 0.0, process 1 enters the system. बट देन इसकी प्रायोरिटी कितनी है? थर्ड नंबर की। उतनी देर में कौन आ गया? P2 आ गया। तो P2 की ज़्यादा प्रायोरिटी है, सबसे ज़्यादा प्रायोरिटी फर्स्ट की है। तो सिर्फ ये कब तक चला? 0.4 टाइम यूनिट्स तक। P1 को हटा दिया P2 because it has got higher priority. Hardly it had run because like this guy is also removed because the highest priority process P1 has arrived और P3 has arrived. किसकी है सबसे ज़्यादा प्रायोरिटी?
P3.
P3 की। उसको पोजीशन 1 पे लाना है। और ये इसलिए पूरे अपना चलेगा। हम इसको राउंड रॉबिन शेड्यूलिंग से कर रहे हैं with time quantum equals to 1 time unit. ओके, तो ये 3 वाला प्रोसेस को सबसे ज़्यादा प्रायोरिटी है। सो ये पूरा 2 तक चला, 1 से लेकर 2 तक। और इसका बर्स्ट टाइम भी 1 था, तो इसने अपना पूरा बर्स्ट टाइम लिया। अब बचे हमारे बाकी दोनों। उसमें से ज़्यादा प्रायोरिटी किसकी है? P2 की कि P3 की?
P2.
P2। तो यहाँ पर P2 आएगा। और क्योंकि ये प्रीएम्प्टिव है, 3 को घुसने नहीं देगा जब तक इसका पूरा काम खत्म नहीं होगा। इसने 0.6 टाइम यूनिट्स यूज किए थे अपने 0.4 से 1 तक, और इसको चाहिए कितने? 4। तो 2 + 4 6 होता, बट ये 0.6 यूज कर चुका है, तो ये 5.4 तक चलेगा और फिर ये सीपीयू रिलिंक्विश कर देगा। एंड देन लीस्ट प्रायोरिटी प्रोसेस इज P3 तो फिनिश हो चुका था, गलती से लिख दिया ये हमने। P3 की तो हाईएस्ट प्रायोरिटी थी, उसने तो पूरा लेके अपने प्रायोरिटी पे अपना काम खत्म करा लिया। Now it was P1, it was there and P1 had used 0 से लेकर 0.4 तक टाइम, और इसको चाहिए कितना? 8। ओके, तो ये चलेगा 13 तक। Got it how I did it?
Yes, ma'am.
Yes, ma'am.
Those who are paying attention have understood it quite well. I'll just repeat. It started at time 0, only P1 was there. Okay, though it had the least priority, third place थी इसकी, but इसको प्रायोरिटी थर्ड देने के बावजूद घुसा ये उस टाइम पे, तो इसको दे दिया, बट उससे ज़्यादा प्रायोरिटी वाला आ गया इसको प्रीएम्प्ट कर दिया गया और P2 रन करेगा अब for remaining time. It had to continue, but what happened? The highest priority one P3 entered. इसको आगे प्रायोरिटी हमने क्वेश्चन में 1 दी है, तो P2 भी प्रीएम्प्ट हो गया और P3 को पूरा अपना टाइम मिला। अगर इसका 2 टाइम यूनिट्स होता तो ये और आगे चलता और किसी को ना आने देता, बट इसका 1 ही है, तो इसने अपने टाइम क्वांटम में फिनिश कर दिया। राउंड रॉबिन शेड्यूलिंग वी आर फॉलोइंग। देन व्हेन इट हैज रिलिंक्विश्ड द सीपीयू, इसने सीपीयू छोड़ दिया, तो बाकी दोनों प्रोसेसेस से चेक हुआ कि P2 और P1 में किसकी ज़्यादा प्रायोरिटी है। P2 की प्रायोरिटी है। देन P2 comes over, it runs for the remaining time slot. It had already consumed 0.6 time units and it has to do for 4, so remaining 3.4 it's given here. It runs up to 5.4. 2 plus 3 becomes 5, 0.4 becomes 0.4, and then your P1 will execute. The remaining time we have just calculated that out of 8 it had used 0.4, so 7.6 remained, and Gantt chart has reached up to 0.4. 5.4 plus calculator showed the remaining time as 7.6. We added them. All the processes get over at time 13. So now what is the turnaround time of process 1? Process 1 कौन से टाइम पे फिनिश हो रहा है? डायग्राम से देख के बताओ।
13 पर।
13 पर ना, और अराइवल है इसका 0 पर, तो इसका क्या हो जाएगा? टर्न अराउंड टाइम ओके। प्रोसेस 2 कब खत्म हो रहा है? When is
5.4.
5.4? So here you will write इसका turnaround time 5.4 minus क्या था इसका अराइवल टाइम?
0.4.
0.4, तो इसका टर्न अराउंड टाइम कितना आ गया? 5। प्रोसेस 3 कब फिनिश हुआ है? 2 पर, and what time it had arrived?
1.
1 is its arrival time, so its turnaround time is 1. So now average turnaround time will be 13 plus 5 plus 1 upon 3. कितना बना? 13 plus 6, 19 upon 3. 19 upon 3 मतलब 6 3s are 18. 1 बचा, ठीक है। This is the turnaround time, and then we can calculate waiting time. कितना है प्रोसेस 1 का? टर्न अराउंड टाइम कितना आया था? Okay. Am I fast?
No, ma'am.
It's okay ना? So इसका 5 कॉपी कर लिया ऊपर से और इसका
1.
1 कॉपी कर लिया। वेट टाइम निकालने के लिए हमें जो हमने टर्न अराउंड टाइम निकाला होता है उसका आंसर हम देख लेते हैं यहाँ पर, और माइनस क्या करते हैं उनमें से हम?
Burst time.
बर्स्ट टाइम। क्वेश्चन से ऊपर देख लेते हैं क्या क्या है इनके बर्स्ट टाइम। 8, 4 और 1। क्या आया? इसका 5 आ गया, इसका 1 आ गया और इसका 0 आ गया। ये तो सिंपल है। 6 डिवाइडेड बाय 3, एवरेज वेटिंग टाइम इज इक्वल टू 6 divided by 3 equals to 2. Fine.
Yes, ma'am.
I suppose we have done enough for today. Okay.
Yes, ma'am.
You
Yes,
also,
ma'am.
yeah, you can revise all these we have done. 2 algorithms in a day are more than enough so that you don't get confused. Now for numerical questions, we have done all of the 5 ones and just theory portion remains that we will do on Friday. No, Thursday. Thursday this time. In this semester, I have got theory class with you on Thursday. Tomorrow we will meet for lab and Thursday we'll meet for theory again. Then I will make you write further multi-level queue scheduling and multi-level feedback queue scheduling. Copied everyone? Should I stop sharing? Or should I scroll up, down, anywhere? Tell me. Okay, then no response. I mean, I think you have all ran away. Okay, see you tomorrow then, okay? Fine. We'll meet in the lab. Hopefully, everything will be fine now.